In this lesson, you are going to learn about what a heating curve is, how to construct one, and how to interpret one. So first we have to start by talking about what it is. A heating curve is going to show the change in temperature over a period of time as a pure substance is heated, usually starting from its solid phase through a series of phase changes, typically from a solid to a liquid to a gas, or sometimes maybe just solid to liquid, or sometimes just liquid to gas, but many times it would show both melting and boiling as well. And of course, this is all going to happen as energy is absorbed by the substance. Similarly, a cooling curve is effectively the opposite. It shows the change in temperature over a period of time as a pure substance is cooled, usually from its gaseous state through a series of phase changes from gas to liquid to solid as energy is released by the substance. So heating, energy is absorbed, cooling, energy is released. Now, in order to interpret a heating curve, we must first construct one. You're going to collect data from a simulated sample of a pure substance. There is a video link in Canvas that you're going to take a look at, and you're going to watch this substance get heated from its solid form. You're meant to observe what is happening to its particles as it absorbs energy. So you're going to keep track of the data at when you open up the simulation or the video. You're going to see at time when it's starting, it's time 0. The temperature is at -20. The substance is entirely in the solid phase, so S for solid, and there's no phase change happening, so we're just going to do a dash. You're going to watch. You're going to play the video and try to stop it as best you can at each minute. Record what temperature it's at. Record if it's purely in the solid phase, purely in the liquid phase, purely in the gas phase, or if you see both solid and liquid, then you should write both of those letters if you see that. If you see both solid and liquid, then you know it's melting. If you see both liquid and gas, you're going to know that it's boiling. So you'll collect this data. Once you've collected this data, you're going to draw a graph of the data, placing the temperature on the y-axis and time on the x-axis. Right? So there should be a piece of graph paper that you can get from your teacher in class. This one that I have for you is already pre-marked. You just need to label. This is going to be your time axis. This is going to be your temperature in degrees Celsius axis. You should create a title, label your axes. When you plot your points, make point protectors. This is not a line graph, so you're going to go dot to dot on this. Okay, it's not a line graph. Don't try to make a single line of best fit. A single line of best fit. You're going to go dot to dot. Okay, once you construct that graph, you're going to write the words solid, liquid, and gas on the parts of the graph where the substance was completely in that state of matter. You're going to write the word melting and S to L, meaning solid to liquid, on the part of the graph where the substance was changing from a solid to a liquid. You'll write boiling and L turning into G, liquid turning into gas, on the part of the graph where the substance was changing from a liquid to a gas. You'll then draw a horizontal dashed line from the area of the graph where melting is occurring over to the y-axis. Label that line melting point and circle the temperature. Draw a horizontal dashed line from the area of the graph where boiling is occurring over to the y-axis. Label that line boiling point and circle the temperature. And then create a title for this graph, heating curve of blank, adding in the name of the substance, which you can identify based on its melting point and boiling point. Once you've done that, you're going to roughly sketch a cooling curve of the same substance on the set of axes below. So here's the set of axes. Label these things on this cooling curve, the general trend is going to be down and to the right because you're cooling down, so the temperature will be going down. And then you'll finish today's lesson with describing the areas of the heating curve, the flat parts of the graph, what's happening with the phase change, and what's happening with the states of matter. These are just meant to be checked. All right. Once you're done with this, you can try the problem set, the corresponding problem set 10.2b. So that's it for this lesson. You've learned how heating curves work, how to graph them, and how to interpret them. That's it for now. We'll see you back in the classroom.